All right, well, thank you. I'm John Barnes, landscape manager here on the campus, and I am here to talk to you about the landscape improvements that we have just completed. In 2007, we began began a program to look at improving the irrigation systems on the campus. And then in spring of 2008, we brought in a consultant to audit the systems and see what the problems were. And with the help of, they looked at our efficiencies and our inefficiencies. And with the help of utilities department, we determined that we used approximately 175 million gallons of water on irrigation to irrigate the campus landscape. This map depicts our irrigation systems on campus. The green represents the automatic systems, and that is approximately 108 acres. The orange are manual systems, 42 acres, and the blue represents non-irrigated spaces. The numbers I'm going to be presenting to you today are based on the automatic systems only. We are improving the manual systems and upgrading those, but that's not part of this presentation. So then the question, why Target Irrigation? Well, like I just said, we used 175 million gallons annually of water to irrigate the campus. And what were our inefficiencies? We discovered, or we knew, and it was pointed out that we had 82 controllers that were decentralized, could not talk to each other, couldn't communicate back. If we had to do anything to change a schedule, we had to go to each individual controller on the campus. We had inefficient sprinkler heads, and we could not make automatic adjustments for weather. We could not do global adjustments to turn systems off. We could not measure irrigation, the water use. The 175 million we had, we backed into that. We didn't have an actual way to measure that. And we had no way of shutting down. If we had a break in a line, we couldn't shut that down automatically. We had to physically go out and turn a valve off. So water wasted during that time. Now, what did we do? What improvements did we put in place? We now have a computerized central irrigation control system that can gather data from the individual field controllers, can tell us how much water we're using, and then we can develop reports from that information. We also have remote control capability for our technicians. It's like a TV remote. I hope your TV remote's not quite this big. It works in the same way that the technicians can go out and take this with them, and it's one technician. In the past, it took two. They can go out and turn the system on, work on it, turn it off, turn it back on, all from out in the field. So it's not two people, one at the controller and one out in the field. It's a major labor savings. Now here is this shows our old existing heads. Look in this area, the mist that's up in the air. If we had any breeze at all, that wouldn't end up where it's supposed to be. That mist would end up over here or over there, and it just didn't hit where it's supposed to hit. And they also put out a lot more water than not more water than they needed, but put it out quickly, and then we would have some runoff or some puddling. These heads were easily clogged and hard to adjust. And so we replaced 13,000 of these, over 13,000 of these heads on the campus. And this is what we replaced them with. If you notice the same area, same time of day too, there's no misting. You can barely see it, but there is a stream of water. There are multiple streams of water, and they're larger droplets, And so the mist, the wind movement doesn't affect it. The water gets where it's supposed to get. It puts out less water. Oh, we have to run them longer, but it puts out less water, so there's less chance that the water will drain off. We also had put in 2 ET controllers, ET gauges, and 3 rain buckets. Rain buckets are self-explanatory. They catch the rain, tell us how much it rained, if it ever rains. ET gauges, evapotranspiration rate. Evapotranspiration is the evaporation of water from the soil and transpiration of water through plants. And these gauges measure that, and then will automatically adjust the system up or down. If it's a dry day, it puts more water out. If it's a moist day or a wet day, it puts no water or less water out. Major labor savings. The next slide shows our, we put in flow sensors and master control valves on every system. The flow sensor tells us how much water is going out for every system. And the master control valve will shut down the system if we have a break, high flow, water flow. It'll tell the controller to give us a warning or an alarm. It'll shut down the system. No wasted water. Major savings on water. We can't measure that amount, but it's going to be a major savings. So, in conclusion, what are the benefits that we receive? Reduction in water. We expect 28% reduction in our water use, and that equates to 49 million gallons a year of savings. And if you put the dollars to that, with 2012 City of Austin water rates, that's over $600,000 annually saved. And at the positive environmental impact, we're avoiding over 300,000 pounds of CO2 production. And labor savings. That was our remote control. Cuts technicians' times in half, plus we don't have to go out in the field to make any adjustments. They're done. You know, it's just, you hit a button, you change it, it's finished. That's it. Thank you.